Okay, welcome to the last part of our review for our test on Friday. This is very, very important right here, and so is this. Um, so, know those, please. Molarity is simply the number of moles of a solute divided by the number of liters of a solution. And so, let's take a look at number 17. Um, Here we go. What is the molarity of 6.4 moles of sodium sulfate in 2.6 liters of solution? Well, you are given the moles and you are given the liters, number of liters. So 6.4 moles divided by 2.6 liters. And if you do the math correctly, I'll even put an answer on there in a second. So just give me a second. Forgot to get my calculator out. So 6.4 divided by 2.6 equals 2.46 molar. That's the solution, okay? Simply division problem. Now, number 18, you were not given the number of moles of magnesium chloride. You were given the volume in liters, and that's okay. And it does say you have to find the number of moles of MgCl first. So I'm going to set the problem up for you. And it's simply this. You have your mass in grams of your magnesium chloride. And then what you have to do is you have to get the molar mass of MgCl2 here, and then that goes under 1 mole of that. So that's a simple division problem. So 36.9 divided by the molar mass of magnesium chloride, and that's going to give you the number of moles of magnesium chloride, MgCl2. And then you're going to divide it by 0.267 liters, and that'll give you your answer. And there's your molarity, okay? Okay, the last two are also going to be on your test. What is the concentration of a solution that contains 40 milliliters of 6 molar HCl and is diluted to 750 milliliters? So we're starting with this actually, and when it says is diluted, that is your equal sign. So this will be our V1, this is going to be our M1, and this is going to be our V2, so we're looking for our M2, and that's going to, we don't know what it is. So let's set up our problem. We always write down an equation first, and then we just kind of rearrange it to find M2. So M2 is going to equal M1 times V1 over V2. So now all we have to do is plug the numbers in where they should go, and the M1 happens to be 6 molar. The V1 happens to be 40 milliliters. And bottom we have a V2 at 750 milliliters. And you divide that out, that'll give you your concentration and molarity, okay? Molar would be the unit. The next one is what volume of 6 molar sodium hydroxide solution is needed to prepare 400 milliliters of a 2.5 molar sodium hydroxide solution? Well, the simple thing to do is set up what we have. Is needed to prepare, that's going to be our equals right there. So this will be our M1, this will be our V1, we don't know what it is. This will be our V2, and this will be our M2. So our equation is M1 times V1 equals M2 times V2, and simply rearrange it to find V1. So V1 is going to equal M2 times V2 divided by M1. And let's plug the numbers in where they should go. So 400 milliliters times 2.5 molar and divided by 6 molar here. And let's plug those numbers in to see what we can get. And so when we do that, it's 400 times 2.5 and divide it by 6, and that'll give us 166.7 milliliters of a solution. Okay, that's what we need. Now go back to number 19. Just plug the numbers in for that one since they're right there. That'd be 6 times 40 equals, and divided by 750, and we have 0.32 molar. Okay, that should be it. V1, M1, good, V2. Okay, hope you don't have any questions, and we'll see you tomorrow.